most of us know that in terms of per capita greenhouse gas emission, India is only 103rd. But we often forget that given our population, we are the third largest emitter of greenhouse gas in the world. And as our GDP grows, as we get out of poverty, we will see that this number only increases. And we will, in probably 10 years' time, will be the second largest emitter. What I think is equally important is to understand that if the greenhouse gas emission really sets off, we are in big trouble. We will be the biggest sufferer. And as I pointed out several times, 2 weeks rain in the last 2 weeks, in 3 weeks in Chennai, saw major areas of Chennai flooded. And even very rich people had to actually get onto a boat to get out of their home to go to a street. And rest of the India is going to get into worse situation as we go on. So whether we like it or not, we have to take it upon ourselves to try to somehow stop this climate change and let the world to heal. Vijay Raghavan also already mentioned about some of the very interesting work that we did about solar DC and motors and all that. I'll take it a step forward. This IIT Madras Research Park where you are sitting, and if you have not visited, you should go out and see the place. This is 1.2 million square feet. It's a commercial park. We decided that we will take the lead by first showing that we can pretty much manage with near 100% green energy, maybe 90% green energy. We consume about 40 megawatt hour of electricity every day. Our rooftop can only give you 10% of that. What we therefore started doing is that we started getting the solar plant set up and wind plant set up outside IIT Madras, somewhere even 100 kilometers away in Tamil Nadu. And fortunately, we could wheel that energy into IIT Madras. So it is possible for us to get about 35 megawatt hour of electricity, green electricity every day. The only problem is that since we are dependent primarily on solar and wind, it will be available whenever sun shines and wind blows. And we have to use it instead. So we have to actually build a storage. And while the electricity from sun and wind cost has come down, we know that the storage cost was extremely high. Except we recognized that 40% of our electricity is coming from air conditioning. You see this right now, we are sitting almost in a very cold and this thing, and 40% of our energy is used in that. This was somewhat easier. What it meant, basically for this air conditioning, what do? We chill the water in the basement of this building, and we circulate the get the air conditioning. What we decided is to build a large thermally insulated tank, and we could chill the water whenever we had excess electricity and use it whenever we needed electricity. And we have done that. So that's the first storage that we built. And that doesn't cost as much. Because we already have the chillers. Anyway, we are going to chill the water. It only meant building a good storage. And in fact, we are going to do some very, very interesting work how to make the storage even smaller. Professor Ranjit and others are actually going to add wings to this whole thing. Then we started building lithium-ion batteries. The lithium-ion batteries for the storage, for the rest of it. That was expensive. And that's where some innovations were required. And a very, very good management, energy management was required. such that as soon as we get the solar and wind energy, we are able to bring it out here, use it, put it into storage, and then use it whenever we need. What was surprising is that as we worked on this, we are able to figure out that today we pay close to 11 rupees per kilowatt hour per unit of electricity. Actually, by doing this, and including the depreciation and interest costs, and interest cost I'm taking is 10%, we find that we can do this at close to 7 rupees 50 paise per unit. So essentially, we will save money. Now, if we can save money, I went to our board and say, we will do this. It's not just the great thing that we are doing 100% green, but we will save money. The board immediately says that what's stopping you? Take the money. We have the money. We are not short of resources. Commercial buildings like this, there are 40,000 such commercial buildings, are not short of resources. There is no reason why they all cannot do this. We just have to show this, make this possible, and then it can be replicated. Then it comes to industry. Industry also use significant amount of electricity, and they can also use more or less a similar approach. Get solar and wind plant. Today only solar and wind is available. Get it out here, put the storage, and get the cost down. Over time, the cost of storage will keep coming down. Lithium-ion battery storage costs will keep coming down. The cost will further come down. So that's the second thing that we do. Then high-income group housing. The kind of housing that I was talking about, which were flooded in recent rains. They pay 7 rupees, 8 rupees. Even they can move to 100% green energy. And together, these three sectors consume about 70% of energy in the country. So we can move fairly quickly in next 5 to 7 years, almost 60% of electricity to green energy. That will be a good beginning. That's not enough, but that's a very good beginning to move us towards the better energy. What is the approach? We decided to do the work along with IIT Madras and Research Park. Together, we create a big group. We decided individual work doesn't get us very far. But when we work together, it can really do wonders. And fortunately, at IIT Madras, we have some of the best faculty in the world. All that we need to get them enthused and take them a step beyond what they normally do. They do research and development, publish papers. That's something that they do very well. We said we are going to commercialize. And we went into 4 stages. First stage is same, research and development. The second stage is pilots. And pilots are designed for 2 purposes. The R&D proves the science, whereas pilots will prove technology at some scale, and it's also going to prove economics. Once you get economics proven, and it makes economic sense, there is enough money in India. Once return of investment is guaranteed, there is no money shortage. Remember that we are starting with a high-income group. We can then go into early implementation, where, of course, we require some policy support and maybe a little bit here and there subsidy, and then full-scale implementation. If we can move the science from educational institute has to move to large-scale commercialization through these 4 processes. And the research park is precisely doing that, taking the science and moving it in that direction. We then started looking at all the potential technology, all the technologies that are needed. Solar, wind is now well proven. Of course, we will probably have to work more and to see that we will be able to do even more by bringing the next generation solar and things like that. The wheeling in energy, chilled water battery, battery storage, management, all of that we'll be able to prove it in relatively short time, in a year, year and a half. The energy efficiency in heat pumps and air conditioning becomes another very important topic. And of course, we have to strengthen our transmission and distribution grid for renewable energy, which is something technologies are known. We have to quickly move to 2-wheeler and 3-wheeler electric vehicles. This is already economically viable and technologies are all known. Quick with the energy management system, these are something that we actually can deploy at scale over the next 5 years. But there are some problems with some things like this. The first problem is while solar energy is generated throughout the year fairly uniformly, wind energy is not. Wind energy peaks in India for about 4 to 5 months and then goes down much, much. We need therefore long-term storage. We need storage which can be there for 3 to 4 months. What do we do? And this was a challenge that was given by, I think, one of you who had come and posed, saying that we need some other technologies. We are working on a number of different things. But one of the things that we found very, very interesting is the work on zinc air and aluminum air. This is a technology. In a zinc air battery, zinc is consumed when you actually give out electricity. And then you can use to recover the zinc by using electricity. And this can be done 3 to 4 months. And our early computation shows that it can be made economically viable. We decided over the next 5 years, we need to make that commercial. Similarly, we are looking at ocean waves, what we can do. Larger EVs and freight transportation will become very important at that time. Green hydrogen will play a very important role. Not as much for electric vehicles, but it's going to play extremely important role for our industry, our steel and iron industry, for our cement industry. It's not going to go anywhere without green hydrogen. And fortunately, a company like Ohmium is setting up its R&D out here, and it's already producing green hydrogen. And we have, since we are bringing green energy out here, we can actually produce green hydrogen. And then the major work will be in carbon capture, sequestration, and utilization. At the same time, right now, starting this year, we can start working on electrifying construction equipment. It is not yet economically fully viable, but in 2 to 3 years, it will become viable. You see construction equipment today being deployed all over IIT Madras. It gives so much of fuels. We can actually convert that to electric. And similarly, agricultural equipment. We can actually convert that. The green hydrogen will also play a major role in ammonia production, which is essential for our agriculture. There are technologies where we don't have as much competence and will take us longer time, like, for example, small modular nuclear reactors. We love to work with some other labs which can actually help us in getting there, or compressed air storage, which some of the people here have been already talking about. But remember, while compressed air storage may be very, very difficult, I'll talk about compressed carbon dioxide storage, which is not as difficult, and we probably will get it as a byproduct of what we are trying to do. Next slide, please. Yeah, so we have a whole lot of factors, including the work being done in policy. I just don't even want to get into the names. Many people are sort of sitting. Next slide, please. And then there are already a lot of ongoing. The ongoing effort includes solar plus wind wheeling power and lithium-ion storage, chilled water storage, energy management for green grid, storage and uses, EV subsystem development, battery swapping, efficient motors and controllers, enhancing cooling and heating efficiency in commercial and industrial buildings, solar system for small and mid-sized complexes, very, very important. DC electricity becomes very important. Recycling of lithium-ion battery. Those who are here tomorrow will see we have set up a recycling plant where we are able to recover 90 to 93% of materials from the battery. And then there are new initiatives. Can we take all our autos and vehicles like Tata Ace and completely convert it to electric? We are showing that this is possible today. Retrofitting agricultural machinery, retrofitting construction machinery, and on and on. Then there are other technologies that we really need to work on. I mentioned about zinc here. And 2 of my colleagues here have said that in 1 year's time, they will deliver something which at least makes complete technical sense and ready to see. Economics, we still have to work. It's not going to happen overnight. But in 3-4 years, we are very confident that we can get it. Then another idea came from another colleagues of ours. We are already putting chilled water storage. Can we use hydrates? I mean, this will not take us more than a year to show and make it commercially viable. Retrofit our 300 kilowatt chillers that we have with not just chilling. We are actually right now, whenever we chill electricity, we then use, it also generates heat, and we are actually wasting that. Can we tap that heat and use it somewhere? Then green hydrogen generation and using it maybe for a small vehicle, and most important, carbon dioxide capture from cement kiln, processing through electrolysis to generate syngas, carbon monoxide, and hydrogen to heat the kiln. Can we actually do that? Again, my young colleagues, they are actually far better than we thought we were good when we came in about 30 years, 40 years back as faculty. Today, all the youngsters are far better than us. We just have to empower them, and they will do wonders. This is one thing that I want to tell our dean sitting here. Just empower, enable, and they will do wonders. Then there is another group which is working. And I was amazed with the kind of work that is going on. Our group in civil engineering, which essentially is very focused on cement. It is a very serious problem. No, India's GDP is rising. What does it mean? It is going to build. If it is going to build, it is going to use more cement. And if it is going to use more cement, which basically means more carbon dioxide. We identified that 35% of the carbon dioxide is used as a fossil fuel in cement manufacturing. There, we are fairly confident that some of our colleagues will be able to deliver green hydrogen in short time. But 65% of carbon dioxide is emitted during calcination process. If we allow that to just go into the air, we are going to destroy the world very quickly. And cement plants are located near limestone locations. How do we really go about solving that? So we realize that we actually build these things with concrete. We can actually sequester carbon dioxide into this concrete. The problem is that the current way of making concrete, where you use steel as the primary reinforcing material, that will corrode when we introduce carbon dioxide. And that's the reason, before we do that, we have actually changed that to glass fiber. There also our colleagues are working quite well there. And after that, we have to sequester carbon dioxide. Actually, we are trying to talk to companies like GAIL and say, today you carry gas, of course, with fossil fuel. Tomorrow, can you carry carbon dioxide in these pipes? And all the way from cement plants, deliver it at the place where concrete is being made and sequester that in this. This is the kind of task that we will require to be done. And as I pointed out, our cement manufacturing group, Professor Gettu, Professor Manu Santanam, and there are several others, were absolutely fantastic. We just have to enable them, get them going and move. What I am pointing out that it was kind of a little fortunate that IIT Madras itself, we seem to have all kinds of technologies. Remember, this is not going to be an easy task, however. There are going to be a large number of policy bottlenecks. I was taking my colleagues that we can work on technology, we can work on economics, but that's not enough. There is one more bottleneck will come. And that will come because of all kinds of legacy issues. For example, most of us know that 15 years back, we used to have a huge shortage of power in the country. And what did we start doing? We started opening more and more coal power plants. More coal mining, more coal power plants. Most of them have been set up in the last 10 years. They have not recovered their money. What is going to happen? Are they going to be shut down? What happens to all the coal mines? Large number of people are employed there. Are we going to shut them down? What about power plants? What about discoms, which loses money? What about the auto industry? One of the largest industry, contributes to 8% of our GDP. Unless we do a transition, we are going to get into serious trouble. And Similarly, our oil sector, refining and distribution, contributing to another 5%. So transition through careful change management will be extremely critical. And that's where I'm hoping that our management faculty, our humanities faculty, along with our engineering faculty can take place. Remember that we need to grow. We cannot stop because we are otherwise a poor country. We cannot impact our GDP. We cannot impact our employment. We need to go green with all this. India and the world needs to move to net zero very rapidly. Our focus is, can we bring ROI, return on investment? And that's where we want partnership to work on technology to enable that. Fortunately, we have immense amount of capabilities which can very quickly come up with technology, and we'll partner wherever we don't have. Wherever technologies are available, we'll pick that up. We are not going to do everything on our own. And then we have some very wise alumni who can guide us when needed. And change management, preserving GDP and employment will be the critical thing for us to win. And we are therefore seeking partnership with academia, industry, and startup to accelerate this adoption. We have to do it. We will do it simply because there is no option. Thank you.